Alright, let's begin. Now, today's lesson, it's all new topics, so everything that you didn't get in quadratics, what I'm going to do from here on is every session you're going to come in, I'm going to have a little quiz sheet, and I'm going to make sure to practice your factorizing, your difference of perfect squares, and completing the square. There's going to be like 5 questions, and you're going to do it, drilling it, until the end of the semester, okay? Because I want you to definitely understand how to factorize from a previous chapter. Though you don't factorize a lot in this chapter, you're going to have to do it part of the way. Okay, there's skills that you're going to learn that you can do, and then skills that you require from the previous step, which is the last chapter. So if you can't do the last chapter, it's going to carry on with this one. All right, so let's begin. This exercise today, you don't require any factorizing. Okay, you only require grade, I think it was 4 long division, or grade 5 long division. Okay, so let me show you. Yeah, it's all right. Let me show you. Let me show you how to subtract. Here we go. I'm going to start off easy just so that you have this concept, okay? 3 times 4. What is 3 times 4? 8. Oh my god. I am worried about our class now, okay? 12. 3 groups of 4 is 12, right? Now let's think about this. If I took 12 divide, which is the opposite of times, 12 divide 4, you told me the answer is 3. But then if I then said 12 divide, which is the opposite of times, divide 3, you should get 4. This is why we say 3 and 4 are factors of 12. Did I just say factorizing? No, you're not. But I'm trying to show you why you've been factorizing, the logic of factorizing. Because all you're doing is you're doing 2 numbers multiplied to each other. It gives you a quadratic or a cubic, whatever it is. When you divide, you get the result. That's the whole idea. 12 divided 4 gives you 3, or 12 divided 3 gives you 4. So, let's compare this to algebra now, because I want you to see it. They're both exactly the same thing. When I say this, x minus 2 times x plus 2. Now, this is what you did in year 7 and year 8. Distributive law. You would have expanded, you said x times x times 3, negative 2 times x, negative 2 times 3. Yeah? And then what you would have got was you would have got x squared, what's that, 3x minus 2x, so plus x minus 6. Yeah? So let's compare it. What I just did was 2 numbers. 3 times 4 equals 12. Yeah? So if I got this divided by one of these numbers, you should be getting one of these results. True? Just the same way you did. 12 divided 4 gives you 3. Or 12 divided 3 gives you 4. So then, logic, if I took x squared plus x minus 6 divided by x plus 3, I should be getting x minus 2. Or if I got this divided by this factor, I should be getting this factor. Does that make sense? Yeah? Okay, so what I'm saying here is if I'm saying x squared plus x minus 6, if I took this and I divide it by x plus 3, what would you expect the answer to be? X minus 2. It's the leftover factor. Or if you said x squared plus x minus 6 divided by x minus 2, it should give you, yeah, it should be x plus 3. It's the other one. So I'm trying to show you logic. Now, what I'm teaching you in this session is how to prove that. We know the answer has to be this. We're going to try to solve it. And the only way to solve it is exactly how you would do it with numbers. How do you know that 12 divided 4 is actually 3? I'm going to do exactly the same way that you would do with numbers, you do with letters. Because that's how letters come about. They come about on how you do with numbers. Okay? So let's have a look. Let's think about 25 divided by 2, which is really saying half of 25. Now what's half of 25? 12.5. Okay, now we know the answer is 12.5, but how you learnt it back in year 7 or grade 6 or grade 5 is you would have done this. You would have said, how many 2's fit into... I don't know how you guys normally learn it. Is it like that? Is how you guys learn the division sign? Yeah? Okay, so you're saying how many 2's fit into 25? 8. Okay, so you can say 8, but how you start off, this is how you started off. You normally do how many 2's fit into the first unit, which is 2 units, or 2 tens. You say it fits in once. True? What's the remainder? 0. Now, the way that you learnt it was short division, where you put 0 over there, or sometimes you don't even put the 0, but that's 0, 5, and you say, how many 2's fit into 5, right? What I don't, that's not how we did it in terms of long division, that's short division. Long division is what you do is you say, well, how many 2's in 2? You tell me once. So 1, 2, one group of 2 will give you 2. The reason why you know there's a 0 remainder is because you're saying the difference between these two, what's my remainder? So you say 0. And you drop the 5 down. This is long division. That's why this is called long division. Whereas if you do it this way, this is shorter because you do once and then you do how many times? Remainder of 1. You do it in your head. You're sort of like, oh yeah, remainder 0. So then you put a 0 here, 0, 5. Then you say how many 2's in 5. It's exactly the same thing. But the reason why I'm teaching this way, because you see the layout. Because that's how you're going to do it for letters. Exactly the same way. Okay, so we're not going to do short division, we're going to do long division. Now that we ask, how many 2's fit into 5? What would you say? 2. So if you think about it, 2 groups of 2 is 4. And then you find the difference. And you say, all right, the difference is 1. Now what you would then tell me is, you can either move into decimals, but with polynomials and algebra, we don't go into decimals. We leave it as fractions. So, how do you know 12.5 as a decimal? You'd say it's 12 wholes plus the remainder, which is 1, out of what were you dividing by? That's why we know it's 12 and a half, which is 12.5. Does that make sense? So what you see I've done here is that 1 is the remainder, because that's what's not making it a whole. Because if it's a whole, then you would have added it. How's that feel? Trent? Why did I drop the 5 down? Because I'm saying how many 2 fits into 2 10s? Yeah? And I'm saying it fits in 1 10s. But this is not a 10, that's a 5 units. So I still have 5 units, 0 10s. Yeah? And that's why I'm dropping the 5 down, because I'm keeping it in units and 10s column. Yeah? Hands up if that doesn't make sense so far. Okay, good. Because now I want you to use numbers, and we're going to compare this to algebra. Now I want you to copy this one down, okay? Because this one is directly exactly the same thing as what you do with numbers. Let's have a look. I said to you before, x squared plus x minus 6 divided by x minus 2 should give you x plus 3. That's what we said. Let's prove this. Let's try to get that. Okay, so same thing again. It's exactly the same way you would do here. You would say, this is x squared plus x minus 6. You're saying how many of these x minus 2's fit into x squared plus x minus 6? Now it's exactly the same technique. See, what you're saying here is you're saying 2 times what gives you close to 2. 2 times what gives you close to 5. Right? Then you're going to do exactly the same thing here. You're saying x times what will give you close to x squared. So what would you times to x to get you that x squared? Another x, which makes sense because what you're saying now is you're saying this is our x minus 2, and you say times that by x. Just like I did over here, that was a 2, and you said times that by 1, and that gave you a 2, and you put the 2 here. Yeah? No difference here. It's absolutely exactly the same. I'm doing the same thing here. I'm taking that number, and I said times it by x, and that will give me that x squared I'm looking for. So I'm going to use another color so you can see. I'm going to say, all right, if I times this by x, now you think about it, x times x will give me x squared, but then don't forget you still got x groups of the negative 2. So I'm going to write it down. So it's negative 2x. See what I've done there? So all I did was I said, how many groups? X groups. What goes underneath is how many times this is. So you said x times x times negative 2 gives you this.
X squared underneath?
Why is the x squared underneath?
Yeah.
Because it's just like how you did here. You said, how many 2's go to 2? You told me once. 2 times 1 is 2.
Oh, okay.
And then 2 minus 2, and you find the remainder.
X times x times.
Yeah. So
minus sign in front of it.
yes. So now we're finding, why do we put a minus sign is because we're trying to see what is the remainder? We want to know what the remainder is, just like you did here. You said 2 minus 2 gave you a remainder of 0. I'm going to do exactly the same thing here. See, I'm going to see x squared plus x. I want to know what's the remainder if I subtract them. So if I do that, let's subtract it. X squared minus an x squared gives you 0. So that's a 0 remainder. But then what's x subtract negative 2x? Plus 3x. So let's be careful here. So it was x subtract negative 2x. See, that is actually the same thing as saying x plus 2x. Two negatives is a positive, yeah? So therefore, what I'm saying here is x subtract negative 2x gives me 3x. So this is my remainder, just like I did here. 2 subtract 2, remainder 0. Yeah, so what did you do over here? You still had that 5 units. I still have this minus 6, whatever column it is.
So it's 3x minus 6.
Fantastic. So what you're going to do now is you say, okay, so I'm still got my minus 6. And then you do exactly what you did before. So what did you do after you got the 0, 5? You said, how many 2's fit into 5? And you told me 2. So 2 times 2 was 4. That's why I put a 4 underneath. And then you found the difference to find the remainder. Now, no difference here. I'm going to do exactly the same. I'm going to say, how many x fits into 3x minus 6? Now, it's easier if we just look at the coefficient. X times what will give you 3x? 3. So then I'd say, all right, what I'm going to do is I'm going to say plus 3. Because positive 3 times x gives me, I'm going to do another color here, 3x. But then don't forget, because this is actually a group. You times this by 3, you also have another group. Yeah, so you times the negative 2 by 3, it's negative 6. Now you find the difference. You want to find the difference and see if there's a remainder. So if you subtract it, 3x subtract 3x is 0. Negative 6 minus minus becomes plus 6, 0. So 0 remainder, and I've finished. 0 remainder, what is my answer? That means x squared plus x minus 6 divided by x minus 2 is x plus 3. Just the way you did over here, you did how many 2 goes into 25? You got 12, remainder 1 out of 2. So that's why it's 12 and a half. Same thing here. Do you see the relevance between the two? So whatever you do with numbers back in grade 3 and 4, exactly how you're going to do it in year 11 for polynomials. The only difference is one's with letters, one's with numbers. How do we feel? Because we're going to do another example and you get your head around it. Have we copied? Good? All right, let's do another one. Let's do this one now. Same drill. Okay, so this one now, I don't know the answer yet, but we're going to write through it. We're going to work through it. Same drill. Okay, then after all this, I'll teach you a quicker method. But that quicker method has a restriction. That's why I want to teach you this one first. This one will work for any polynomial. The next method I teach you will only work when the denominator is a linear equation, meaning it's a power of 1. Okay? But for now, let's do what you're meant to learn for year 11. Cubic division or polynomial division is what it's called. So here we go. Same drill. You are asking how many, I should do a vertical line. How many x plus 2's fit into x cubed plus x squared minus 14x minus 24? That's what you're asking. Okay? So we're going to do the same drill again. We're going to say, how many x's fit into x cubed? So x times what will give you x cubed? What would you say? X squared. So we're going to say, all right, x squared. So x squared is going to be multiplied to x plus 2. So x squared times x gives me my x cubed that I wanted. Good. X squared times positive 2 gives me positive 2x squared. Good. Plus 2x squared. Next thing is you subtract it because you're trying to find the difference. You want to see the remainder. So the nice thing is we know the x cubes will cancel out to be 0. We should do it in another color. I'll do it black so it's consistent. So it's 0, and then you say now x squared minus positive 2. So 1 minus 2 gives you negative 1. So it's negative 1 x squared. That's my remainder. What do you do next? Yeah, you bring the whole thing down because that's your remainder. This is your leftover columns. You bring it down just like the other one. You brought down the 5. Well, now you bring down the whole thing. So I'm going to bring down the whole thing. I'm going to bring negative 14x and I'm going to bring negative 24 because these all come together as 1. So here we go. This is my next line. I've got negative 14x minus 24. Okay, same drill. Now we're back to square 1 again. Yeah.
The minus x cubed plus 2x squared is going to be a fraction. The 2x squared is going to be negative.
This one?
Yeah.
Yep. Oh yeah, I see what you mean. Yes. It's always bracketed. Yes. Okay, because we're saying that number subtract this number. Okay, so yes, it is bracketed, so therefore it's going to be a minus 2. Okay, so it'll be x squared minus 2x squared, which is negative x squared. Alright, drop down negative 14x, drop down negative 24, and then you begin again. Same thing again, you then say, how many x plus 2's fit into the second line? But it's easier just to look at the first coefficient. I want a negative x squared. Yeah, so you times it by negative x, so I'm going to write that down. I'm going to write, okay, negative x, because negative x times x gives me negative x squared. But then don't forget, because you're multiplying it to x plus 2, you also have to multiply to the 2. So negative x times positive 2 gives me negative 2x. I'm going to write it down, negative 2x, and obviously with the 24 I have nothing, so I'm going to do plus 0. And I'm just going to leave it as plus 0. Now, what you're going to do next, I'm going to bracket it. And then I'm going to say, find the difference to find out the remainder. That's what I'm going to do. Find the difference. And it just so happens that if you find the difference, 2 negatives become positive. Negative x squared plus x squared is 0. Then, negative 14 minus again makes it positive. So negative 14 plus 2, which is negative 12x. And then you got negative 24 minus 0. Well, you're subtracting nothing, so you got minus 24. Okay? So that's my remainder. Now that's my remainder, and finally, I want to finally get to the last end until I get the final remainder. I'm asking how many x fits into negative 12x? Or x times what gives you negative 12x? And you would say? Negative 12. And so here we go. We say, all right, negative 12 is my answer. And it makes sense. Negative 12 times x is negative 12x. But don't forget, you're multiplying it to both of these terms. So negative 12 times positive 2 gives me negative 24. Now I'm going to bracket it again. And you're finding the remainder. So how do you find the remainder? Subtract them. And it just so happens that it works out nicely. Now some of the other examples aren't going to work out nicely. Okay, because I'm going to try to push you to do it in fractions. So what does that mean? That means x cubed plus x squared minus 14x minus 24 divided by x plus 2. The answer is a quadratic. X squared minus x minus 12. Now why did I want you to be able to do this? You can see this is a step from cubics. You've got quadratics. From quadratics, from the previous chapter, now you can factorize that. Because you already got the first factor, you got x plus 2, you need to know what these factors are. That's why you got to learn to factorize. That's what I'm saying, I'm going to keep revising. So on Monday I'm going to give you a quiz, you're going to have to be able to do cross method, difference of perfect squares, completing the square, you have to be proficient. Okay, because that's how cubics is embedded. That's why I said at the start of the year, I said if you don't have quadratics, it will carry on. And that's how it's carrying on. Okay, because everything you learn is a stepping stone to the next one. Okay? Now, let's try the other method now. This method is called synthetic division. Okay? For those of you who found all the x's difficult, this only works, and I'm going to highlight, only works if the denominator is a linear equation, meaning it's to the power of 1. If you have the power of 2, it doesn't work. Okay? But this one will conceptually look easier. Okay, it will be perceptually easier. Okay, so let's have a look. How does the method work? I'll show you. It is so easy that you're going to prefer this method over the other one, but I need you to know both. Okay? Here you go. This is how it works.
That only works if there's 1
if it's to the power of 1.
So if it's like, so if it's 2x?
That's fine. But there's another technique I got to teach you on top of that, which I'll show next session. Okay? But for now, we're just going to deal with 1x and x to the power of 1. Okay, then you can use this method easily. Later on, I'm going to show you how to do it when it's 2, 3. Okay, but right now it only works for you, what I'm going to teach you today. You're going to be able to do it when it's 1x plus whatever minus whatever. Okay? This is how easy it is. Synthetic division. Some other teachers teach a different type of synthetic. This is my synthetic. Okay? You're going to write, because we hate these letters. True? So what we're going to focus on are just numbers. So we're going to look at the coefficients. We've got coefficient of x cubed, which is 1. Coefficient means number in front of, or number multiplied to. So it's 1, 1, negative 14, negative 24. Yeah? So that's what I'm going to write. I'm going to write 1, 1, negative 14, negative 24. See, no x's. Makes it easy. So that means, now this is the only trick about this one. And remember, all this that you're doing, you're going to memorize for me. Okay, it's just the technique I'm showing you. If you want to know what goes out to the front, because you're removing all the x's, rearrange this. Imagine it was equal to 0. So let it x plus 2 equal to 0. Solve for x. What would x equal to? Good. So that is the number that you're going to put out here. There is a logic to all this, but for now you're going to memorize this, okay? So negative 2. Now, this is how the technique works. I call it like the stop and pop. All right, so you stop, you pop, you stop, and you pop. Now this is how it works. You just simply, the first step, always, you drop down the 1. Or whatever it is, whatever this number is, you drop it down. So you start off with 1, so this is stop, and you're going to pop. How do you pop? Times the negative 2 to the 1, and you pop it over here. Okay, so negative 2 times 1 gives you negative 2, so I'm going to pop it over here. So I'm going to pop it over here, negative 2. 1 subtract 2, because that's a minus there. 1 subtract 2, negative 1. So I'm going to put a negative 1. So I've stopped again. Now you're going to pop. How do you pop? Negative 2 times negative 1? Positive 2. Thank you. So you pop. You pop it here, positive 2. That's negative 14 plus 2. Negative 12. Then that's stop. Now you're going to pop again. Negative 2 times negative 12? Positive 24. And then finally, negative 24 plus 24? 0. Now what these numbers represent are the coefficients of your quadratic. See, this is 1. This represents 1x squared minus 1x minus 12 plus 0 remainder. That's what it is representing. So that's your 0 remainder. And you were dividing it by negative 2, so it's 0 out of negative 2. Or technically 0 out of x plus 2. Okay? Or you can just ignore it, because 0 divided by anything cancels out. But that is your quadratic, and is exactly what I got. 1x squared minus 1x minus 12. Absolutely the same. Yes? Except for that one.
Yeah, how do you know it's 3x?
Because, and this is why I'm saying it only works because x cubed, when you divide by an x, it's always going to be an x squared. You see, like if you got x cubed and you divide that by x, where is it? Oh, here. X cubed divided by x, it gives you x squared. That's why it only works for cubic. That's why I'm saying, just if you're going to get this, it only applies to cubic.
X4 over x2.
Yes, you can do the same, but you know that if you divide it by, you can't do it x squared. It has to be an x. If you did x4 divided by x, what are you going to end up with? Cubic. Okay? Quartic. Quartic. Quarter, so quartic. So it would be like this, quartic. Then quintic. Then I think heptic or hexic. Then septic. I don't know my Latin. You guys tell me. Okay? How's this method? Do we understand this method? Yes? Stop and pop. It's faster and easier, takes less space, but it doesn't work for everything. This works for everything. You can go to specialists and you can still do this with complex numbers. It still works. This one, no. Okay? So that's why I'm showing you that method first. So you got to know how to do this, but you're going to find this one easier. Now, let's do another one, just so you get used to this. Let's try it the long method and then synthetic. But I'm going to get you to do it first, and then I'll do the answers. Okay, so I'm going to give you, just because it's your first time, I'll give you 5 minutes to spend on that. Okay, so it's a long time to do one question. Take your time. Write it out. Okay, so the trick thing with this one is I didn't write the x squared. What would you do? Write it out. Same drill. You can check your answers with both divisions. They should both come out to the same answer. So 5 minutes and then I'll write up my solution.
Yeah.
2 minutes left. Have a look at your answers, check the solutions. Both of them should be the same. See 3, negative 6, 13, negative 29. How you write the remainder, negative 29 out of what you were dividing by. In our case, it's x plus 2. So right down here, you should be adding up here, you should be saying minus 29 over x plus 2. Both answers are the same, both techniques. Jamal? Say? Plus 0x squared. I wrote it just so that you can see the columns. I'm trying to keep the columns. Sorry? Yeah. But because it wasn't there, if I didn't write that, then it will look weird because you have minus 6x squared and then you have x here. And it might confuse you. I just put it in so that you can see the columns. So it's nice. So if you think about it, if I highlight it, this is the x cubed column. And that's the x squared. And that's the x. Oh.